This video provides a brief demonstration of our omitted variable bias module. We study the concept of omitted variable bias using the example of the relationship between test scores and the number of hours a student spends studying. So in observational data, we often see a flat or even negative relationship between studying and test scores. In other words, more studying isn't associated on average with higher scores and maybe even with lower scores. As a professor, I indicate to the students that I find this puzzling and that perhaps omitted variable bias can help us solve this puzzle. So I remind them that omitted variable that could cause bias is a variable that is a determinant of the outcome, 1, and 2, that is correlated with our regressor of interest. So in this example, I'm going to suggest study sleep hours as a potential omitted variable, right? One that's a determinant of test scores and is also correlated with study hours. Right? So in order to study how omitted variable bias comes into play in this relationship, I'm going to think about 3 parameters. Beta 1, the coefficient on study hours, delta, the hypothetical coefficient on sleep hours and its relationship with test scores, and the correlation between the number of hours spent studying and sleep hours. So I start by asking students to think about what these population parameters might be. So what is the true relationship between the number of hours spent studying and test scores? Now, I don't mean what we see in the correlation we see in the data, but imagine if we did a randomized controlled trial and assigned some students to study more. Right? So how about I assume that on average, each additional hour of studying is associated with 3 more points in study on the test. And how about sleep? Let's assume that sleep also has a positive impact on studying, and maybe it's just as positive. Each additional hour of sleep is associated with 3 higher points on the test. Now, we can play around with this and we can come back, and if the students want to suggest different numbers, we can plug them in here. The third thing I need to think about is what's the correlation between the amount of time spent studying and the amount of time spent sleeping. And since there's only so many hours in the day, I'm going to suggest that the correlation is probably negative and probably quite high. I'll suggest a correlation of negative 0.9. In other words, more studying is associated with less sleep and vice versa. More sleep is associated with less time left in the day to study. Okay, so given I've set up a parameter of a positive beta 1, a positive delta, and a negative correlation. Given this data generating process, I can generate a scatter plot of the relationship that I see and the naive regression line of a simple regression of test scores on study hours. And here I see, as I suggested, a pretty flat and actually negative relationship between study hours and test scores. In other words, more studying is associated with lower test scores. So at this point, I'm going to remind students of the omitted variable bias equation that we've looked at earlier in the class period. And we remember that beta 1 hat, my estimator of the slope, the relationship between test scores and study, converges in probability to the true population slope, plus, if there's an omitted variable bias term that's equal to delta times the covariance of the regressor of interest, in this case study, and the omitted variable, in this case sleep, over the variance of the regressor study. And while we may not know the exact value of delta and covariance, we can certainly use our economic intuition to think about their signs. So if I could think of the sign of delta and the sign of covariance, I'd be able to assign the omitted variable bias term. Right, and we've said that we think delta is positive. More sleep is associated with higher test scores. And we've also said that we think the covariance is negative. More studying is associated with less sleep and vice versa. And since variance, which is here in the denominator, is always positive, the numerator, the positive times the negative, tells us that the omitted variable bias we're going to expect in this case is negative. In other words, the naive slope that we estimated in our regression is going to be too negative. Okay, and if we were to, instead of omitting sleep from our regression, we were to include sleep in a multiple regression of test scores on study hours and sleep, we could re-estimate this equation and get a less biased estimate of beta 1. And that's what happens when we click the show corrected regression line. This shows a line where the slope is from a regression that's including both study hours and sleep in the regression. And what we see is that, in fact, the original naive regression line was negatively biased. And in fact, when we correct, we get a positive slope, as the professor might have suggested would happen if we studied more. But having used this basic example, we can come back and play around more with the parameters, right? And sort of reinforce this point that omitted variable bias occurs when you have a omitted variable that A is a determinant of your outcome and B is correlated with the regressor of interest. So what if it were the case, right, that more study is associated with less sleep and vice versa? In other words, the correlation is negative. But what if sleep didn't have any impact on test scores and we put a 0 in here for delta? Now we can regenerate our data and the naive regression line. And now if we now re-estimate the regression and put sleep in the model, what we see is that the corrected regression line is exactly on top of the naive regression line when we weren't including sleep in the regression. And we can come back to our omitted variable bias equation and recall that what would happen if the correlation here between sleep and study, we had a negative correlation, but what we just did is we changed the delta to be 0. 0 times a negative is going to give rise to 0 omitted variable bias, which is exactly what we saw here. Right? Even if sleep and study are negatively correlated, if sleep doesn't affect test scores, then omitting it from the regression doesn't result in omitted variable bias. Conversely, you could say, okay, yes, sleep does have a positive relationship with test scores, but if the correlation is 0, okay, when we plot our naive regression line, we're going to get the exact same slope as when we include sleep in the regression. Now the intercept is different in this particular case because sleep is impacting test scores in a case where even if we study not at all, but the slope of the naive regression line and the corrected regression line are the same, because if sleep and if study and the omitted variable aren't correlated, there's no omitted variable bias. Now, in this scenario, we're talking about sort of my economic intuition about the sign of the relationship between study and test scores and sleep and test scores, et cetera. But students can really play around with this and even sort of imagine different outcomes and regressors and play around with what would happen if, for example, we had a negative slope on the regressor of interest. So let's get a negative slope on the regressor of interest and a positive correlation or a negative correlation, right? And they can explore what would happen under this scenario, right? In this case, we've got a negative bias, or flip around the correlation this way and see what kind of bias I would expect under that scenario. Right? So it's set up to explain easily the test scores and study hours example, but it can be used more flexibly if we think about plugging in a different regressor of interest for study hours and a different omitted variable for sleep hours. So there really is quite a bit of flexibility to use the module to play around with different examples.